bloop. We're recording. All right, so let me tell you, this section is all over the place. First off, it's easy. Like the first half of this is no problem at all. We're going to do a little bit of Desmos, scientific, and that's it. And then it gets difficult for no reason at all. And I have notes all over this. And what I'm going to do is kind of do a little small notes and show you what's going on. But I have to go to the homework in this section. Like literally, the section after this is fine. But this section is one crazy thing. So we're going to do it together. Is that cool with y'all? So if you have a computer and you wanted to pull up the homework with me later, that would be awesome. So let's do some of this here. I'm going to fill this in. This is population proportion. So it's just the proportion, or say like probability, the percentage of something or other. So 50% of Americans are female. There you go. That's a proportion, right? And so what we're going to do is find out what it is. Wow, look, P for like probability. And doesn't this kind of look like selected over total? Wow. We remember that from back in the day, like a couple weeks ago. So it's the smaller number divided by the bigger number. Okay, so we have two numbers right here. Blah, 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 blah. What would be my smaller number up here? What's the smaller number up here? It ain't 18. Yeah, the 458 divided by, you got it. Right there, divide, done. I'm telling you, that's not too hard, and it's really straightforward at the beginning of this section. So if it were just this way the whole way through, it would be no problem. It says, how likely is the proportion of all adults to be the exact value that you just calculated? And it's just, the word is impossible. I don't know if that's actually on the homework, though, but they're trying to say, if I take a poll of everybody in America, will it be exactly 45, 1, 2? And then probably not. You know, even if it's 45, 1, 1, it would be different. Good with this, though? Okay, easy math so far, easy math. I don't even know what to put there, so we're going to keep going. So really what the idea here is that we're going to do a plus and minus. And I'm going to give you formulas when we get to this, but right now it's pretty easy. We're just doing plus and minus. It's mean plus or minus your error. And this is some kind of an interval. Have y'all done, some of y'all have done algebra, right? Where you got like domains and ranges and stuff. That's kind of what's going on here. It's like a domain. And so, you know how domains in algebra are like negative infinity, positive infinity? Well, and then sometimes they're like from 2 to 3 or something like that, 4 to infinity. That's the kind of idea here. We're just trying to find the two numbers on both sides. So we have a mean and we have a margin of error, and we're just going to go on both sides of it. So here I got 0.52 minus the 0.04, comma, 0.52 plus the 0.04. And this interval is, hello. This interval is telling me where the population proportion could be. Oh, I don't know why I'm doing commas and parentheses. I just want to find the numbers. But I'm glad you're here. You're very bright today. And there we go. Cool. Now, they haven't really gotten into the whole depths of why we're doing all this yet, but the idea is that we have an average and we're going plus or minus. That's literally what the error means, is that we're going plus or minus from the mean. And essentially, like on a bell curve, you have the mean, and then you just went plus or minus some amount and said anything in between. That's all it is. Cool so far? Can we add and subtract? Hello. So here's another one. We're going to do the same thing. What would be my mean? What's my average? Looking at this big thing up here. Like, what number would I say is my mean? I know it's a lot of words, but you're looking at numbers, right? What's my average? What's my mean? Perfect. You got it. You got it. What would be my error then? Done. So I'm just going to plus and minus, basically, right? Plus and minus. So yeah, 26.25 minus the 6, 26.25 plus the 6. I should be able to do this by hand, right? Yeah. Yeah, answer. It's very similar in its concept. What we're going to do is there's like a formula that they're going to use here in a minute. And of course, StatCrunch does it all for you. But it is a slightly different formula going forward. I mean, I would scroll, but it would just be you'll see it here soon. That's a great question, though. That's an excellent question because it's very similar. It's basically the same concept. 32.25. There you go. 20.25. Yep, correct. I'm subtracting and then I'm adding. That's all I'm doing. There you go. So now what they're wanting to do on this next one is to go backwards. They've given me the answer, the interval, and now they're saying, what was the average? How much plus and minus error did we have? We can find it through algebra, but that's like way too much work. I'm just going to give you the formula. And so here it is. The mean is the upper plus the lower divided by 2. And then the standard error. I mean, really, I just want to call it error if you don't mind. I'd rather just call it error. The error is the upper minus the lower divided by 2. And that's what we're going to do. So do you see how we have a lower and an upper? That's what we're doing. Here's some math. So I got 4.9 plus 3.5 divided by 2. And then we got 4.9 minus 3.5 divided by 2. And there you go. You're done. There's nothing else to talk about here, I guess. It's just a formula. This is not too bad, isn't it? Isn't this nice? Right? I love this. Yeah. 9.1. Yep, we're doing 9.1 today. Yep. I know it seems like it's ahead, but then we're not going to be seeing each other on Tuesday, and I have to review for the exam. So, yeah. That's my mean and my error. Hello. Yeah. My mean, my average, and then the standard error, kind of like a standard deviation in a way. Yeah. But the math is okay, right? I'm not concerned about that math. As long as you have those formulas, we're good to go. Hello. Okay, so we're going to do it again. This one has just one slight difference at the very, very end, but as of now, we just need to find the mean and the error. So I got my two numbers here. So how would I find my mean? Remind me what I'm going to type into Desmos. Yep, 4,1. And what do I do here? Plus. Yep, 3,3. Very good. Divided by. Perfect. And then on the bottom, I'm going to do the 4,1 minus the 3,3. Perfect. 100%. Let's do it. Yep. There we go. Sweet. Okay, cool. 3704. This is the math that I like doing. Now, they have one extra small question up here about it. See this like 1,000? So we found the proportion, we found the error, and I say mean, but really this is that proportion every time, but it's just the average, it's whatever. And it says the number of individuals in the sample with the specified X, I'm a little confused about what they're trying to ask for, but I'll tell you what it is here. You take this number and you multiply it by the 1,000. So whatever you got for your average times that 1,000. I'm going to do the calculator just in case. Can never be too sure. So they're saying in a sample of 1,000, we're expecting around 370 to be confident in their something or other, blah, blah, blah. Okay, cool. Yeah? Okay, cool. So that's the last part that they're asking for. Check my audio, and we're good. Okay, cool. Is that okay so far? The math's okay? Yeah? It's just simple math. So I have a star here, and then I put question marks. I think what's happening is that on the homework there's a single multiple choice, and then you're just going to click that thing. But really, what they're trying to talk about is the confidence interval stuff. Now, how I traditionally think about it is about our confidence. I want to do like a small mini lecture. Is that okay? Like I kind of just talk for a second. Okay, so confidence intervals is that I'm this much confident about my results. Okay, don't read this. Think more like Chad's going to just do his own thing. So I'm 95% sure about this. Yeah, I'm only 80% sure about this. Okay, so here's a statement. I'm going to make a statement. We're going to talk about it. 50% of Americans are female. I'm just going to make that statement. Okay, cool? So, how confident am I in that result? Am I 100% confident? No, because I can't be. What if it's 51%? Then I'm totally wrong, right? So, can I be like 95%? It's going to be pretty close. Checking the audio, okay, guys? Oh, there it is. It's back on. I wasn't talking loud enough. We good? Okay, we're good. Okay, cool. Now, this is going to be a timeout. This is where things start to go down a dark road on the homework. There's a multiple choice somewhere on the homework that talks about this one. Okay, so this is a multiple choice on the homework. And yet, they also want you to do a little bit of math on it. So it's not just multiple choice. There's a little bit of math. We're going to get there. I'm going to show you the homework for sure. But this is on the homework, this little formula thing, okay? And then, I don't know if you can see, but I have a lot written on this page. But it's sideways, because it was so much. I'm going to try to tell you what's going on here. So this is what I'm going to try. On homework number 9 and homework number 10, there is a multiple choice disaster. I'm just going to call it. It's a multiple choice disaster. Okay. So I'm going to write some of the words that we're going to find when we get there. A sample can be assumed, and this is like one of the boxes. There's a billion of them, so just kind of hang on with me here. And then they're going to have this n p 1 minus p. Okay, so that's another box. And then equals, and then there's going to be like some numbers in here. I'm going to put just some random numbers. We're going to have a different set of numbers here in a few minutes, okay? So something kind of like that, comma, and it says greater than or equal to, and that's another box, 10, and then therefore the, hold on, the sample size, this is for your homework. I mean, I wouldn't be doing this unless it was important. The sample size can be assumed, that's the second time, to be less than 5% of the population size. Oh my goodness, this is one part of a very long question. I'm going to reread this because it's a lot, okay? And I'm going to try to zoom in a little bit here. Let me get over to the side. Here we go. So on number 9 and number 10, the sample can be assumed to be this NP 1 minus P that we were just talking about right here. And I got a 300 on mine. We're going to, when we do the homework in a minute, we're going to get a different number. But that's greater than 10. Is 300 greater than 10? Yeah, a lot. And then they say, okay, well, therefore, the sample size can be assumed also to be less than 5%, blah, 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 blah. And that's this part right here, but it's, you can't really do any math with that, so you just click some things. This is one part of a very large problem, okay? But now you have notes. When you get to this problem, you click those boxes. You get me? That's why we make the video too, right? Because then you can come back and look at what was Chad doing here. Yep, Chad's still good. Cool? I will show you in a few minutes. I have to keep cruising though, and get the workbook done, and then we'll go back to the homework. Flip the page. Hey, didn't I say it was number 9 and number 10? Number 9 and number 10, huh? Yeah. Okay, cool. Let me zoom out a little bit. So, I have a continuation. On the homework, number 10, part 4. I would not write this down unless there was a reason, okay? So I had a confidence interval of 0.474 and then 536, and I had to select possible, not likely, possible, not likely, and then does not contain, and then I can't even spell contain today. I'm working on it. Does not contain, and then they have a 0.6 here. Okay, now all of this is answers. All of these are separate boxes. I'm going to zoom in a little bit so you can see it a little bit more, and I'm going to repeat it. So on my particular numbers, I had these. And again, when I get to number 10, I'll show you. But on part number 4, you have to click these other guys. And notice that my interval here is going from 0.4 to 0.5. Yeah? Is 0.6 inside of that? No. It's kind of like a domain thing, right? Is that inside my domain? No, it's not. And that's what I'm trying to say. It does not contain. Right now, these are just notes for you to get through the homework. Are you okay with this? I know it's a little bit weird, like, what are you talking about, Chad? You're going to know when we get there. Part 5. I would not be telling you unless it was important. You have to trust me. This is just, it gets so insane. So they're looking for the opposite proportion. Opposite proportion. okay? And so what I did is I did options edit, and again, I will show you when we get there. You're going to see it all again. And I change my boxes in StatCrunch. I put a literal minus sign in here, and then there's my total, and then I just put the rest, and it was fine. So that's successes, and this is my total. Let me scroll down a little bit. That's successes, and then that's total. I think that's the last one I have for a little bit, okay? If you have questions on like what I'm writing, tell me. But otherwise, I'm having to get it down so you have it. The rest, though, the workbook kind of gets better after this. That's the 1024, and then see it's like a total, and I'm going to be subtracting something from it. But again, I'm going to show you the more specifics here in a second. It's just kind of weedy on this number 9 and number 10. Okay, but you have it written down, right? Now you got your notes. Okay, cool. Just so you have it. All right, cool. Good? Okay, now let's back to the workbook for reals. We can actually do the real math now. So, moving on, they're saying find these confidence levels. So what they're trying, and I have no idea what this thing is. We're not going to fill that in. What they're trying to say is that there's 92% in between. So like, what would it look like to have 92% of the bell curve shaded in? What about if I only had 87? Look at how good my bell curves are. What do you think? Is that awesome or what? Just me joking. That's just me joking. So that's 80. That's 87%. But where would these lines end up? That's the question. What do you think I'm going to go to find these numbers? What do you think? StatCrunch. I want to make that picture happen. StatCrunch for sure. Let's do some StatCrunch action, okay? And these are very simple things. And it will be on the homework. It'll look just like this thing. All right. We're going to go to Stat, Calculator, Normal. I believe we've done this a whole bunch, but I'm just going to remind you how this works here. Stat, Calculator, Normal. Stat, Calculator, Normal. Here we go. I'm going to click between, and then immediately at the bottom, I just put 0.92, and there we go. Look at that picture. Copy paste the same picture. Now they're wondering, hey, what are these numbers down here? Well, I got them. Negative 1.75, 1.75. Those are my answers right there, aren't they? Very straightforward. For 87, what am I going to do for that? Exactly. Thank you. Type 0.87. Same thing. Look at that awesome picture I drew, huh? I'm just joking. It's like the worst ever. Cool. Now, on the homework, they're actually a little bit more particular. They're wanting just the positive values. So, like, the actual answer that you're going to type is just the positive number. But it's just because it's a plus minus and it doesn't really matter. Just give me the number. Cool. Stat, Calculator, Normal. Yep. So like I was saying beforehand, this confidence level. So I'm going to say 50% of Americans are female. So then I want to be confident in my answer. What if I were 92% confident? What if I were only 87% confident? The numbers will change a little bit, and that's why we're changing our bell curves in a way. Is this okay so far? Easy math, right? It's easy math. We're about to get to on the homework. Oh, all I did was change the number down here in the bottom corner, and then boom, it was done. I put between, and then down here I did for like 92. I put the 0.92. 0.92. Did you do between at the top? Yep. And then 0.92 and nothing. Don't change anything else. Hello and hello. Here I'm coming. All good, all good. Glad y'all are here. Okay, cool. Now, again, this homework is going to be crazy here in a few minutes. This table is super important to you. I actually referenced this table in like totally other different sections. I'm going to say go to the table on page 139, I think it is, right? 139. I literally use this table a lot. You can always go and do these numbers yourself. It says 90%. So what if I put in a 90%? 1.645? Isn't that the same thing? What about 95? What if I put a 95 in? 1.96? Right? So we can always find it regardless, but these are like the common numbers that happen. So you can go back to these real quick. Like, I don't think we're going to use them right now, but they're here. Okay. Finally, we get like another problem to do math on. Yep. We're doing some stat crunch. Here we finally go. So we got some amount surveyed, and some say dissatisfied, this and that. They say, assuming this distribution is normally normal, then find the confidence interval. What they didn't state in this problem, unfortunately, is that it's going to be a 95% confidence interval. They did not state that on the problem, so I have to like tell you that's what they were trying to say. That's what the homework says. And we're going to go to StatCrunch now. All right, so let's take a look for a second. I want to be 95% confident in whatever I'm going to state. Yeah, and I went and surveyed all 450 women, and I said, "Hey, are you dissatisfied?" And 135 said yes. Okay, so I want to make a public statement about women being dissatisfied, and I want to be 95% confident. What can I say about all of the women in America? Does it make sense? What range am I going to find for all Americans? Okay, is it going to be exactly whatever this guy is right here? No, it's going to be somewhere in a range. You getting me now? That's why we're going to do that interval. So here we go. Let's do some stat crunch. And this is brand new. This is the actual fun stuff here. Stat, and we're going to go to proportion stats. One sample. Oh man, it's not big enough. Let me scroll this a little bit. Hold on. Let me get this. Proportion stats, and then one sample with summary. So stat, proportion, one sample with summary. And let me write that all down one more time. So we went to stat, proportion, one sample, and then with summary. And we're going to use this like 20 times here in just a minute, okay? Stat, proportion, one sample with summary. Let's put in the numbers. And this is where it's super easy. We just let StatCrunch do it all for you. Successes. That's my smaller number. What would be my smaller number here? 135. You got it. What's my total? Oh, sorry. What's my total? 450. Notice it says right here confidence, and then they have this like level, and I'm telling you it's a 95. They just forgot to write it in the problem. Yeah, it's already in there. Exactly, because that's the usual one that we always go to. Yep. I'm going to hit compute. That was literally all you had to do. Your answers are here. You're done. Here's your lower and your upper limits. This is the interval in which I can now state blah, 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 whatever. So let me put some stuff down. We had, go ahead. It's the lower, right here, the lower and upper limits, the ones at the very end. The L and the U. So I'm writing down on my notes just what I was putting in there. But it's up to you what you put. And then I'm going to like say I went to the confidence interval. And then under level, I had a 95. And I hit compute and I got a lower limit and an upper limit. Did you click on confidence? Here, let's try that. So see how there's this confidence here? You have to click on it. And if you don't, and then, yeah, you click on it and then you hit compute, it should show you these lower and upper limits now. Stat proportion once. Yep. 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 135. 450. Yep. Confidence. Very good. Yep. Yep. Exactly. Hit compute, and then you get your answers at the far end there. Oh, you're good. You're good. No, you're good. You're good. I'm glad it works. This is your answer. That's the confidence interval. And on my math lab, they're going to have just two boxes. You just put the two numbers in there. So let me finalize what we're trying to say here. I want to know how many women are dissatisfied in all of America. I want to be 95% confident about whatever I'm going to state in the magazine, right? Because I want to put it in a magazine. So I won't go out and I say, okay, 450 women survey you. What do you think? I got 135 say dissatisfied. Awesome. I put it all in, and this is what I should put in the magazine. I'm going to say I'm 95% confident that somewhere between 25 to 34% of women are dissatisfied, and I'm 95% confident with it. Okay, that's what I'm going to say. It's somewhere between 25% and 34% of all Americans, of all women, are dissatisfied. Oh, yeah, I don't know how much to round. They'll say. I think it's 3 decimals. Yeah, but you got the right idea. Okay, cool. Does that make sense? We're going to do this like 20 times, and it's going to be done. It's going to be easy. We're just going to StatCrunch with 3 numbers, okay? Cool? Any questions? Yeah. Yeah, I'm here for you, yeah. Let me check my audio. Make sure I'm... Yep, we're good. It's just cables. Yeah. Sometimes it's just weird. You know, CTC equipment here, you know what I mean? Okay. Let me scroll this a little bit here so I can get more. Okay, so in a survey of 3,000, 14 say they pay bills online, 99% confidence, go to it. And like we've already done this, super easy now. So, stat, proportion, one sample with summary. Of course it had to be that way. Okay, stat, proportion, one sample with summary. So, I'm looking at my numbers here. What do I put in successes? 1422 total. Perfect. Confidence of 99. You got it. Hit enter and you are done. Now, I'm going to write this down so that you have it, of course. It says 99 in this particular case. It will be changing occasionally. 95 is the default. But yeah. And then compute, and you are done. That's the end of this problem, literally. Level of 99. Hit compute, and there we go. So my lower limits, my upper limits, you put the 2 in, and you're done. 44, try to make that a little bit clearer. 44.8 and 495. There we go. There's your answers. And again, in my math lab, there's going to be 2 boxes, like most of the time. It'll just be 2 boxes, and you just put them both in, and you're done. So, I want to know how many Americans are paying bills online. Okay? And I want to be 99% confident about whatever I'm saying. What if I were only 50% confident? No one would care, right? So I want to be pretty strong, but I can't go like 100% because then it would be impossible. It would just be like anything. And so what I'm going to do is 99%, and then I go out and survey 3,000 people. Pretty nice. And I get this many say they're paying their bills online. So then I compute, blah, blah, blah. And so in the next news article, right, I can say, hey, I'm 99% confident that for all of America, we got 44 to 49% of people are doing bills online. Cool? Somewhere around there. I don't really know because I didn't survey everyone in America, but it looks pretty good. Cool? That's what we're saying. Yeah.
It'll say that, yeah. Yeah, it'll tell you how much. I don't know. I can't remember. Oh, look, look, look. Oh, I love this. Okay, so this is exactly a copy paste of what you'll see on the homework. Always answer with confidence. And right, what shouldn't you do that anyways? Don't you? Whenever you go on a test, you're like, I don't know. No, you answer with confidence. Boom. You feeling me? And this is how you're going to remember on a test. They're going to say blah blah blah, all these options. You're always going to click with confidence. Okay? And we're talking about who? I mean, I know we sampled some folks, but I really want to know about all of America. Which one would be all of America? Would that be the population or just the sample? Population. There you go. So with confidence, boom. I want to know all of America. Every single time. Those are the two things you're looking for. Population with confidence. Every single time. It never changes. Good? Okay, good. Awesome. All right. This is an awesome one. I love this one. This is the perfect opportunity in an algebra class, I would say. Now, y'all do it, but, well, I can't just guarantee that y'all are all sitting there waiting for me to do it, so I'm going to do it with you. But that's okay. So, I'm going to go back to my StatCrunch for this one. And I want to know about Abe Lincoln. So I got my 3 boxes, confidence level. Okay. So in my successes, my smaller number, what would I put in there? For this 181 for the successes, but the total would be, yeah, 1006. Very good. And then my confidence for this particular one is 90. There's your 3 numbers. 1, 2, 3. Pop it all in. Good to go. Again, I'm going to remind you, this is stat proportions, one sample with summary. I'm just going to put sum. Those are all just acronyms, I guess you can say. So here we go again. Stat, proportion, one sample, summary. Here we go. 181, 1006, confident. I want to be 90% confident. You hit compute, you get some numbers. Here we go. 160000, and then I basically get 2000 if you round it. So basically, they're saying 16 to 20%. So I want to know about Americans and what they're thinking about Abe Lincoln. So I go and I want to be 90% confident whenever I publish this in the history something blah blah journal. I survey 1,000 people. This many people say Abe Lincoln. And so then I can confidently say 90% that all of America would say somewhere between 16 to 20% for Abe Lincoln. Is that cool? Making sense? All right, cool. So then you would answer with confidence that the population is blah, 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 Abe Lincoln. Good? Okay, rock and roll, man. Awesome. Do I have something in my notes here? Hold on for a second. One more second here. No, I don't have anything right there. Everything's good. Okay, keep cruising. I got easy stuff, and then the very last bit, I have a little bit of notes that I got to talk about, and then we're going to go to the homework and sit there for the rest of the class, basically. So only a couple more problems that are kind of just, at all, here on the workbook. I think that's, I can do this just a tiny bit. Okay, so they're doing a survey about how you feel about air travel. You feel safe traveling in the air, blah, blah, blah. And they want to be 90% confident, and they have 1,045 adults that they're asking. Where are they asking this particular question? Exactly right. So we need to go to the U.S., and that's my percentage. That's my proportion. So it's going to be a little different when I start putting in the boxes here, okay? So let me tell you what I'm going to be doing here in my boxes. Confident level, and we got a box. Okay, what I'm going to put in my box is I'm going to put the 1,045 times the 69 that I got from over here. That 69 I'm putting in like right there. I've simply put in my total, confidence of 90. So let me show you what that looks like over here. Stat, proportion, one sample with summary. I'm going to type it exactly as I see it. 1045 times 69%. 1045, confidence of 90. You see how I did that automatically there in StatCrunch with the time sign? Could you go and find what 69% of this much is? Sure. But like, I don't even care. Right? And that's why this one's in the workbooks that, when we come to the homework, you could do this kind of problem. Yeah. Times that, yeah. Yeah, and it's going to be perfectly happy. Yep. So there we go. I got a 66646, and then I got a 71353. Again, round to whatever they say. There we go. So I could say with 90% confidence that somewhere between 66 and 71% of Americans think it's safe to travel in the air, blah, blah, blah. Of course, we got to round this to 2 decimals, right? 6-7. Okay, sorry. I just, once in a while, I actually get to do that in a math class. Cool? Someone told me that that was like old now and that there's some new ones coming out. Someone said, no, man, now it's like 41 or whatever. I don't know. It's like, oh, did you hear that too? Oh, see? I'm on the cutting edge right here in a math class. For reals, I got it right? Boom. Look at that. So it says, hey, what about 99% confidence? What will I do now? Like if I go back, what am I going to change? Not the 69. I'm going to change my confidence. Yeah, exactly. Yeah. A 90. Oh, okay. So yeah, a 99, change it to a 99, hit compute. And then we got some new numbers. I got 65 and 73. There you go. And now they're going to ask the question. See, I'm going from 67 to 65. I'm going from 71 to 73. And it's kind of weird. Like, you almost got to see it on a number line. I was here at 6.7, and now I'm here at 6.5. I was at 7.1, now I'm at 7.3. Didn't I go outward some? Did I go outward? And so it says, what happens as you increase the level of confidence? I'm going from a bell curve that looks like this to a bell curve that looks more like this. It increased. It increased. So you can say increases the width. You can say makes it wider, makes it bigger. But you know what's interesting about these bell curves? If you go back, this was 90, and this is 99. This is my 90. This is 99. That's what I expected, though, isn't it? Right. If I say, hey, put 90% in a bell curve, it's going to look like this. If I say 99, it's going to look like that. The end. Right? So that's easy. So yeah, it increases, right? It increases. Awesome. Okay. I don't have it. I don't have it actually. I have nothing else other than what I got there. My workbook says something different though. That's kind of weird. Yeah. My workbook's actually wrong. I had messed up. It gets bigger. Okay. Like, duh. I don't know what I was thinking. Anyways, keep cruising, keep cruising. Hey, this is an interesting problem. I love these kind of things. It says, open up the data file in StatCrunch and go through it, blah, blah, blah. The what? Hold on. Let me make you a StatCrunch button, okay? Isn't that what the StatCrunch button kind of looks like, right? All right, here we go. I'm going to go ahead and I'm going to open up StatCrunch. Right? I mean, no. We're not doing that. There's another one like this later, and we're not going to do it because we're going to go to the homework. That's what they're trying to say. They're trying to say, go to the homework and look around. Okay, so we'll see that again. Okay, this is the last page of this section. So it's just one little quick thing, and then we're done, and we're going to go to the homework. I have to say though, these are the last 3 questions on your homework, and they're very important, very easy, but also let's work through it. Okay. So here we go. Minimum sample size. I have a question for you. I'm going to say 50% of Americans are female. How many do I have to go out and look at? How many Americans do I have to poll? Do I have to go and view to see if I'm right or not? Do I only need to go to 5 people? Would that be enough? Here, let me do 5 people. 1, 2, 3, 4, 5. There it is. I chose 5 people and 0% female. That doesn't make no sense, right? That would be really dumb. So what I'm saying is we need a sample size that's going to be sufficient for what we're talking about. What's that number? It's going to be this formula here, okay? So this is just telling me what that is. See you later. Thank you for being part of my survey. It was just funny. Anyways, so here we go. I'm going to plug this in. I'm going to show you how to do it. It's very simple. So I want to be 90% confident and within 2%. And they say, go ahead and find the minimum sample size for eating leftovers. Easy enough. So it says, no preliminary estimates available. And so this particular rule applies. And it's called the 50-50 rule. What it's going to do is it's going to maximize your minimum. I know it's kind of weird, but it's like a calculus thing. Hey, you're in pre-cal, so you know all about it. Okay, so anyways, this is how you're going to do this problem. Very, very simple. 0.5 times 0.5, and then times, and this is where it gets a little weird. We're going to have a z-score divided by my error. It says within 2%, so I'm going to put a 2% down there, and I'm going to put a square. The only thing I'm missing is this z-score right there. The z-score. So, how do I get this z value? It's actually from the table on page 139. Remember, I was going to reference that, right? I said that, yeah. And I'm going to go to the 90%, and I'm going to go get that number and pop it in. So here we go. I'm going to go back. Page 139. Scroll back up. There it is. Right here, you got it. 90%, 1645. Now, Chad's been doing this a while. Chad has memorized this table. You don't have to. Can you put that table on a formula card when you go in the test? Yeah. Oh, yeah. Oh, yeah. Please. If you don't put it on there, I'll write it down for you. Oh, yeah. Yeah, so that's a pretty important table. There's a couple other numbers that are not in there, and that's where we would use StatCrunch to find those. Like 92 is not in there, but they just don't ask that very often. We're good? Okay, so yeah, 1.645 is what I'm going to put in there. And we're going to go to Desmos, get the number, and we're going to be done with that part of the problem. Let me go and find my Desmos. Yep. And let's put that guy in and see what we get. So I got a 0.5, 0.5, 1.645 over this 2%. And then I just got to square the whole thing. Notice my square is only for those two numbers there. 1691.265. What they're going to say is I always have to round up. That does not look right, Chad. That's why we have to round up. That is a times. That is correct. Yep. There's the parentheses as shift, and then the... Yeah. And then I do a division thing. There's like the fraction buttons and stuff. They have the fraction? The slashy sign, right? Here, let me come on by. Are y'all cool with what I did there, guys? Yep, and then at the end, make sure you put the 2. So that's a power is what that would be. At the that's okay. That's okay. That's why I'm going to be here. Make sure my audio we're good. Okay. Anybody else need help on that? 'Cause it's a little weird. So I go here to the side. So you can hit that button or you can shift and six. Yep. Yep. Up. Two. Yep. Go. Very good. Good job. All right. So it now says that we need to do the whole survey over again, but now we got some extra information. They're saying 11%. So in a way, it's not a 50-50. See, what's the opposite of 11? 89. And so that's how we're going to style this one. We're going to do the 11, and then the 89, and then everything else stays the same. So all I'm going to do is change my two numbers in the front. Everything else stays the same. So I got 11, 89. Now I got a 662.29. What am I actually going to be putting in my math lab? Yep, 663. Because again, I always, right here, I always need to round up. I need to round up here. Okay. Yeah. And it says, what happened to this minimum sample size when I knew more information? It went from 1,600 down to 600. So what happened from here to here? What happened? What would you call that? Smaller. Very good. It got smaller. I mean, that's I don't know. That's good enough, honestly. Okay. Cool. So as another extreme example here, let's see, like, I'm going to say 50% of Americans are female. That's a pretty general thing, right? I'm going to ask a weird question. Who in here likes pickle-flavored ice cream? Oh, for reals? Oh, okay. One, maybe? So is that a weird thing to ask? The more extreme something is, the smaller amount of people you need to go and sample before you're like, yeah, nobody likes pickle-flavored ice cream. I'm so sorry. It's okay. Yep, 11 and 89 are opposites. That is a correct statement. Very good. You got it. That's exactly right. 1 minus the 11 is the 89. That is how we got it. Very good. Okay, so I have something real quick I got to add right here on your homework, okay? Real quick, this is important because it's going to be weird. Homework number 14. What we need to do on the question is a data sort. And we're going to sort var1. It'll make sense whenever we get there, because right now it's kind of all vague. See you later. And then we're going to count the up. We're going to count the up. And then finally after that, we're going to do stats, proportion. We're going to count the up. Yep, I know that sounds really weird, but that's what we got to do. Count the up. And then after we're done with it, we stat proportion 1, sample with summary, like usual, okay? So that's going to be the oddity on number 14. Finally, number 15, I got something else I got to say. They have an N, they have a P hat, and then they're going to say times this 1 minus P hat, and it needs to be greater than or equal to 10. I think that we're going to put in some numbers, and it's just going to be a stat crunch. For a quick example, 1 sample with summary. It's the usual, same thing, you got it. So for an example on this one, we're going to do like a 100, and say the proportion's 25, then we're going to also do the opposite, would be a 75. That number is bigger than 10, so we're good. That's kind of what we're going to go with here, okay? But that's just that same formula we saw earlier. I want to go to the homework. I want to go to the homework and show you number 10. number 9, number 14, number 15 in particular. So here we go. Oh, they kicked me out. That's not cool. 9.1, and I want to. Well, I'm going to walk through a couple of them, but we're gonna definitely have to get to the number 9 and number 10. Okay, so it says find the proportion. Look, we got a smaller number here, and we got the total. I am not worried about this at all. Number 2, it's multiple choice. Yeah, with confidence. Okay, cool. Let's keep cruising. This Zeus thing. Hey, it says to use tables. I got a question. When have we ever used tables in this class? Oh, well, yeah, I suppose you're right. There's that one time. Well, not here on this one. That's funny, though. You're right. I'm going to pull up StatCrunch, and I'm going to remind you what we're doing with this problem. It's not hard. We're going to go back to stat, calculator normal. Stat calculator normal. I already wrote this on the workbook. I'm just reminding you here. Between, and you put in the 85, and then you get your numbers as soon as they let me have the numbers. There you go. 2 numbers, or it says 2 decimals. 1.44. Is that what you? Okay, so they only want the positive. I already said that earlier. I put between, so that was stat calculator normal, and then I went to between, and I put in 85 because they said 85. Now, I already did this. That was on the workbook, but I just want to make sure that you see it now. That's what it looks like on the homework. I'm going to keep cruising, though, okay? I'm not in a rush. I want to make sure that we cover the things we need to cover, you know what I mean? Cool? I'm going to keep cruising. That was an easy problem. We already talked about it. Here we go. Okay, next one. Do it again. Next one. So lower bound, upper bound, we had a question exactly like this. Again, it's the upper minus the lower divided by 2, that kind of thing. Easy stuff. Copy, paste. Keep cruising. Where are we? We're on number 7. Lower bound, upper bound. I think that's all. I don't think we use that at all. I'm going to let y'all figure that one out. Super easy, truly. Okay, easy stuff again. That's just StatCrunch. We type it all in. We're good to go. Number 9. Was number 9 one of my things? Let me flip back and make sure. Yep, number 9. Oh my gosh, here we go. So they say find the point estimate. And so that's very simple. It's just going to be this guy divided by that guy. It's selected over total. No problem here. Let me pull out my my Desmos. Okay. So what would be my smaller number? Out of those 2 numbers, what's my smaller number? Perfect. Divided by? There we go. And we're done with that. That's super easy. Thank you. Okay. And then, boom. That's annoying. It's annoying. And I'm saying, I'm sorry, I'm going to say that on recording. It's annoying to see that, you know. The next one's even worse. But we can get through this. Hey, didn't I write this down somewhere on my workbook somewhere? I know I wrote this down. Okay, here we go. The sample can be assumed, and then we're going to do that formula right there. And then I have to find the number. To be able to find that number, I'm going to do the n, which is the 2282, and then my proportion is the 178, and I'm going to multiply it by the 1 minus 178. Like, what's the opposite of 17? Is like 83-ish, yeah. But it's going to be, oh, didn't I actually write that number down on mine? 333 point, what do they want? 3 decimals. Yep. I'm just reading from my workbook here. It says greater than 10, sample size, can be assumed, 5% of the population size. There you go. So I wrote all that down on my workbook. Now you know why I did it. How long would you be sitting there with this thing, right? Wouldn't that be annoying? That's why I do the homework first, so you're not annoyed. I'm annoyed. But then I show you how to do it, okay? Are we cool with that? Okay, cool. So then it says construct a 90% confidence interval. This is the easy side. We're going back to StatCrunch now. So let me finish this problem up. Back to StatCrunch. Stat, proportion, one sample with summary. Done this 100 times now. We're going to do it again. I need the smaller number. What was my smaller number again? At the top? 406. What's my bigger number? And then confidence, and it says right here 90%. So I'm just going to put a 90%. And there's my two answers. So let me put this to the side. And there's my two answers. Okay, so there is a blank chance. I don't think I've ever used that word here in this section. There's a blank confidence. Oh, we done that, yeah. And my percentage is the 90. They said 90% confidence, right? It's right there. And then we got two boxes. They say 3 decimals, so 165. Do you see where over there 165? And then this guy, what am I going to put? 191. Yeah, I know it's kind of tiny. I'm sorry. But you're right. It's right there, 191 and the 165. Yeah, copy paste. You got it. And there it is. That was not too bad. Number 10, it's going to get worse. So number 10 was like, there was a lot of notes on this one. Was it? Oh, is this it? I went back to number 4. Gosh. Okay, number 10. Here we go. Same kind of question. Kinda. So what I'm going to do ahead of time, is I'm going to put in my numbers right now into this thing. Smaller number, 528. Bigger number, 1019. Confidence, I don't really know. I'm going to put a 95. It doesn't really matter. But I'm doing this right now because this point estimate is automatically computed for us. Compute. See, it's got all these numbers. You see the sample proportion? That's my average. That's my selected over total, I guess you can say. It's already done for me. So I did not have to look at any charts. I do not want to do any charts. Never, never. If I can help it, at least. Hey, look at that. Didn't we already do this? Here we go. Can be assumed. This thing. Which... Oh, and I have to find that number? Oh, man, we got to find that number. Okay. That's fine. That's why I'm doing it beforehand, right? So here we go. I got the 1019 times my 518 times 1 minus the 518. 254.4420. Greater than 10. Sample size. Can be assumed. Population size. What did I do wrong? Greater than 10. Sample size. Can be assumed. Cannot be assumed? What are you wanting from me? What did I do wrong this time? NP this. Did I put this in wrong here? Did I round wrong? 3 decimals? 254. Isn't that it? Did I do something wrong? I'm going to check it. Let's see what we got. Show me what I got wrong. Oh, it is stated to be. No, it said somewhere over here, blah, 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 and it said it somewhere. Oh, yeah, you're right. Simple random sample. Something like that. Normally distributed. Did they say that somewhere? I don't know. Well, watch out, guys. Number 10. We're not done with number 10, let me tell you. This was just part B. Yeah, we got some more to go. But do you see how this little dude right here can be very annoying? I'm annoyed now that you are not, hopefully. Okay, yeah. I don't want you to be annoyed by this. I want you to get through it and feel confident, right? I want you to feel confident. I'm not going to be able to get to all the rest of the questions. I want to finish this one and be done for the day. But let me just finish this one up. Is that cool with y'all real quick? So they say 95% confidence. I got my numbers. Let me go and put those in right quick. 95% confidence, 0.487, 549. Awesome. Pause again. I know I wrote something down about number 10. Number 10, part 4. It says that I need to have possible, not likely, does not contain. And notice they had the 60% right here. That's what I said and put down was the 60%. Possible, not likely, does not contain 60%. I'm telling you, this is what we got to do. Last bit, we're almost there. Part 5. Part 5, it says to redo everything, but we have to change our successes. So what I'm going to do is options edit, and I already wrote this down on the workbook. Options edit, we change this guy to look like that. We had this number only. I just put my total and put a subtraction sign now. I know we're about to leave. I know. I'm sorry. We're so close. See, they're talking about like necessary versus not necessary. They're just trying to do the opposite. Yeah, it's all in the words, but I have to go and show you what to do because otherwise it's just. I got very frustrated when I saw this. I'm so sorry, but that's why I'm trying to do it with you. It's the cheese and no cheese. Very good. That's exactly right. That's exactly what it is. It's a cheese, no cheese. And there you go. See, it worked. We're done right now. I'll finish this up next time. Again, no class on Tuesday. I'm going to post a video about chapter applications instead. See you on Thursday for a review. Cool? Peace out, homies. Thank you.